recording from up there. You're being recorded. So I have a video recorder, so it's recording what you see, and it's recording what I say. Okay? So good morning, everyone. This is October 1st, and we're doing Cornell notes on passive speech. Okay. So concentration. This is your first set of notes. Concentration. Okay? Concentration's fancy definition is this. The amount of solutes in a solution. Okay. Now, let's talk about what we think that means. Okay? Do you guys hear, who's going to eat Kool-Aid?
Wait, what? I never drank Kool-Aid.
You guys all know what Kool-Aid is, right? Okay, it's the powder, and you have the water, you mix it, and all of a sudden you have like high fructose corn syrup drink. Okay? Okay? So it's called. Good way to get it. Okay. So if I was doing it, I had my water. Okay, I have my water. How would I make a high concentration Kool-Aid drink? What would I do? Would I put a lot of powder or a little powder? A lot of powder. So we're going to write that down over here. Okay? Lots of Kool-Aid powder. Okay? A little bit water. Okay? Now, if I wanted to fix my Kool-Aid and make it more dilute, and it could have a lower concentration, what would I add to that? Water. Okay? So I would have a little Kool-Aid and a lot of water. And I can change the concentrations, right? So if you guys take biotech, you will spend so much time making concentration in solutions. Okay, so this seems like we're simplifying it with Kool-Aid, but it's actually something that is very, very important to science. Okay. So imagine, when you guys, has anyone ever been in the hospital and had medicine given to them through like a little a bag? You have an IV in you. If you had surgery, you probably had that. Okay, if the anesthesiologist, the person who puts you to sleep before your surgery, okay, who has been had a surgery where they've gone to sleep? I got my tonsils out. And I'm with you.
I got hit by
Really? Really?
Yeah. Some little girl didn't like it.
Like a toy tire.
Yeah, but it was.
I thought you were talking about the real tires. I was like, wow. Okay, but if you're in the hospital, okay, that's what I need everyone to be quiet. James. Okay, if you're back, if you have a solution, you're getting stuff to put you to sleep. If they give you the wrong concentration of medicine, what do you think happens to you? Do you ever wake up from that sleep? No.
No.
Okay, if they give you too high of a concentration of medication, okay, you might die. Okay? If they don't give you a high enough concentration, what might you do in the middle of the surgery? Imagine waking up while they're burning your tonsils out of your mouth. I need you to raise your hand if you have questions. Yes, they take this really hot rod and they burn off your tonsils. It's called cauterizing. You're asleep during it, but let's keep on going to concentration gradient. Okay, concentration gradient. Concentration gradient is a difference in concentration in a substance from one location to another. So over here, we see a concentration gradient. Where is the difference? On this side, is it high or low? On the left, high. And over here, it was low. Okay? When I first sprayed it, where was the concentration? Where were all the molecules? They were on this side of the room. And you guys have very few molecules in your side. Okay? When we move down a concentration gradient, we move from high concentration to low. That makes sense, right? When you move down a ladder, you move from the top to the bottom. So if I'm going in this direction, I'm moving down. Okay? When we move up a concentration gradient, we move from low to high. Okay, so we're moving from low to high. Okay, on your little papers you got that look like this. Okay, look for the concentration gradient. Okay, look at them and tell me. You can even do this directly into your notes. Okay? Not that. These little ones that say types of path transport, you can feel directly into. Okay, now, over time, after 10 minutes, were all the molecules evenly spread out? Can anyone still really smell it at all?
No.
Is that because the molecules are gone?
No.
No, are they just diluted?
They're diluted.
They're diluted. They've gone to famous, they've gone to four, they've gone to ascend, they've gone to that substance, pressing throughout your specific group. Okay? We would say that the molecules are something called equilibrium. Okay? Equilibrium is when the can you see this in the back? Okay. Equilibrium is when substances are evenly spread out in a solution. So you even write yourself a little note and remind yourself after 10 minutes of spraying. Okay, and do you see over here how the molecules are equally spread out? So I want you to take, we're not going to get through everything. Okay. I want you guys to take a look, and I want you to look at your pictures, okay? And I want you to tell me, okay, is there a concentration gradient, or is everything in equilibrium? Everything, like label each one. They test it. So tell me, is there a concentration gradient in each one, or is there or the molecules in equilibrium? So for this one, is there a concentration gradient, or is it equilibrium? For this one, is there a concentration gradient, or is it equilibrium? For this one, is there a concentration gradient, or is it equilibrium? So take a second to look at it, figure it out. Do we get the first one together? Okay, so over here, how many molecules are on this side? 2. Okay, how many molecules are on this side?
4.
Is there a concentration gradient?
No.
Yes. Yes. Okay. Why? Because the molecules. Why, Rose? Okay, so it's because there is more on one side than the other, right? Over here, okay, Giselle, how many molecules are on this side, on the top? 7. And how many molecules are on this side? 4. Is there a concentration gradient, or are they equilibrium? Well, which one? Concentration gradient or equilibrium? So are there an equal amount on each side? No, so there's a concentration gradient. You get that? Equal. You know how like equal? So these are kind of like inequalities and then equilibrium. Now let's look at this one. This is kind of hard. We don't see this one. Let's count how many are on this side. Well, let's do all the red molecules. Okay, how many red molecules are on this side? There's 10 red molecules. And now here we have 3 red molecules. Is there a concentration gradient? Yes. Right. Right. Now how many blue molecules are there? 11 blue molecules, so this is red. This is blue. 1, 2, 3. So is this more equal? So these are in equilibrium. We're talking about molecules. So either answer between you right for this. Makes sense? No? Give me a distance. Put your finger up if it makes sense to the side of it, okay, and down if you have no idea what I'm saying. Okay, Jay. So what do we understand? Can you help me? Because it's similar, if there's an odd number, so you like have spread off. I guess you say so this one would technically be at equilibrium, but this one over here. But you could say just because it's an odd number and the molecules are moving. So let's say that these molecules are moving. We'll write kind of. Okay? Okay. Well, let's go back to concentration. So that's concentration gradient versus equilibrium. Let's go to the next thing. Passive transport. Okay? Passive transport. The definition of passive transport, and I'll highlight it, so we're reading as we go along, is the movement of molecules from a high concentration to a low concentration using no extra energy. Using no extra energy. So when I sprayed the perfume over here, did I push it to you or did it naturally move towards you? Naturally. Okay? Did I use extra energy or did I use no extra energy? So was that a form of passive transport? Yes. My molecules move from high concentration to low concentration. Okay? We're going to do the 3 types of passive transport. The 3 types of passive transport are this. So if you want to make a little concept map in your notes, so it's like this, cancel passive transport, 1, 2, 3, osmosis, diffusion, and facilitated diffusion. That might make sense. Sometimes I like to make concept maps. I feel like it helps. Right? So types of passive transport. The first type was the movement from a high concentration to a low concentration, simply, which is called diffusion. So when I sprayed it, was that diffusion, would you say? Yeah. So that was diffusion. It usually is across a phospholipid membrane, which is a fancy word for a cell membrane. I'm just going to let you know what your homework is right now. Your homework is to do Q column and summary on Cornell notes. So now our second type is osmosis, which is a type of diffusion, but it involves the diffusion of the water. Okay, so it just means it has nothing to do with that cartoon osmosis zero. Makes no sense to concept. We just gave that word, gave to it. But it has to do with the diffusion of water. So, do you think that might have had to do with your case study? When the guy put water in the blood instead of saline, do you think the water might have been diffused somewhere, like into the cells? When it rained, okay, and the fertilizer, the water had moved somewhere into or out of the cell? Yeah, so that's osmosis. We're going to go into a lot of detail about osmosis tomorrow. Okay. And then our third type is a facilitated diffusion. This is movement from a high concentration to a low concentration by way of a protein. So if you guys look at your pictures that I gave you, you didn't see the protein chain. What I want everyone to do in their facilitated diffusion paper is I want you to label the protein. Label the protein. So label the protein on a little piece of paper I gave you that says type. You might know that you're doing right. Okay, I just want to go over some pictures with you. Okay? So here, where's the protein picture? Someone want to tell me what it looks like? It's yellow, it's the middle. This is the protein. Okay? And we'll talk about this a little bit more. Right? This is osmosis, so you might want to label it osmosis. I think I labeled it for you, right? Okay? So we have facilitated diffusion and diffusion. There are three types of fast transport. Right? I'll do this. Okay, so your homework. Your homework is to do your Cornell finish your summary and keep on. We'll do another set of Cornell tomorrow. We'll also, on Thursday, but we'll also